Hello students, good evening everyone. I hope all are doing well. Welcome to the Infinity Learned by Sri Chaitanya. This is Miss Surya, your chemistry mentor for this particular session. So today we are going to the next session of the same chapter, metals and non-metals. I hope you guys have revised the topics we have covered in the last class. Hi Arush, good evening. Okay, in the last class we have seen about the physical properties of metals and non-metals, right? So here today we are going to discuss about the chemical properties of metals and non-metals. We are specifically focusing about the reaction of metals with air as well as water. Ready? So those who are watching the particular session, just mark your attendance by hitting the like button. Okay, let's start our session. First one, the reaction of metals with air. So, as we already know, in the case of air, there will be major case of oxygen as well as water is present, right? So, in case of air, this constitutes of gases and water vapors. Hence, particularly, the metals react with oxygen as well as moisture. No, Arush, there is more properties are there, physical properties, chemical properties. In chemical properties also, we are going to dealing with the reaction with acids also, which we will be covering on the next class. Okay. So, particularly the metals are reacting with oxygen as well as water vapors here. So, first one we are reacting with the oxygen. Yes. The metal and oxygen reacting with to form the metal oxides. Right? So, the metal oxide which is formed by the reaction of metals and oxygens are generally basic in nature. So, they are vigorously reacting with the acids. Yes, you have already covered, right? Acid, base and salts. This is again we want to repeat in this chapter also, specifically about the reaction of metals and non-metals in acids. So here in general the metals are reacting with oxygen to form metal oxides which are basic in nature. Let us see some examples here. Here is our first image. This is our sodium which is reacting with oxygen in the air, right? So 4Na plus oxygen to form 2Na2O. It is forming the sodium oxide. So what you are observing here, it is easily catches fire, right? It is easily catches fire, which means that sodium is highly reactive metal. Can anyone please give any other example like this, which is easily catches fire, which react with oxygen? Okay, here you can see that if you are taking a piece of sodium metal, when it open in the air, it will catches easily fire, right? Is there any other example? Yes, correct. Potassium, right? Say Arush, very good. So potassium is also forming potassium oxide. So this also easily catches fire, right? Which means that the sodium and potassium are highly reactive metals. Next, the next image is showing that this is our calcium metal. If you are taking calcium metal, we need to provide some heat here, right? That's why we are using the burner here. Which means that as compared to sodium and potassium, calcium is less reactive, right? So in case of calcium metal, whenever it is reacting with the oxygen, it will again form in the calcium oxide, but the reaction rate is very slow as compared to potassium and sodium, right? Potassium and sodium. Thus we are using a burner here. Clear? As Arush, you need to learn these reactions. There is no any specific technique to memorize these reactions. Only the thing that whenever any of the metals which is reacting with the oxygen, it will definitely form the oxides, right? Now, we have already seen that whenever any of the metals which is reacting with the oxides, they are generally forming the basic oxides, right? But there is exceptional cases are there. If you are taking aluminium or zinc oxides, for example, if you are taking aluminium oxides, Al2O3 or zinc oxides, what you are observing there, it can act as both acid as well as base. Such type of property is known as, such type of oxides are known as amphoteric oxides. Amphoteric oxides, right? So, in case of particular metals, for example, in case of aluminium zinc, they react with oxygen to form the particular oxides. These oxides can react with both acid as well as base, known as amphoteric oxides. I hope you understand. Clear? So, let us see the reaction detailing here. The aluminium is reacting with oxygen. Balancing is very important here. I hope you have studied about the balancing of chemical reaction in your first chapter, right? Chemical reactions and equations. So here 4 aluminium reacting with 3 oxygen to form 2 Al2O3, that is aluminium oxide. Now we have to see that how they are reacted as a acid as well as base. Yes, Al2O3, right? Al2O3 is first reacting with the hydrochloric acid, HCl, hydrochloric acid, right? So this is the acid. Whenever it is reacting with the acid, it will act as a base. It will act as a base, right? So it will form AlCl3, that is a salt plus water. So this reaction is known as an acid-base neutralization reaction. Clear? So here in the case of aluminium oxide, it can act as a base in the presence of an acid. For example, is given here for the reaction between hydrochloric acid. Now let us see how they are. Arush, AlC3, which component is? AlCl3. Now let us see how they are reacting with the bases. Same salt, right? Al2O3, same oxide I am taking here, Al2O3, reacting with the base NaOH. This is the base, right? NaOH. It will form 2NaAlO2, that is sodium aluminate. This is another salt known as sodium aluminate. Plus water. Again, they are forming the salt, right? Which means they are reacting with the base to act as a acid. Is that clear? So this is the reaction of Al2O3 with the acid as well as base. Okay, how we can call AlCl3 as an oxide? Is there any oxygen present in it? AlCl3. It is a salt which is formed by the reaction between acid and base. Clear? Now let's take the another example of zinc oxide. Zinc oxide is another example of the amphoteric oxide. 2 zinc is reacting with oxygen to form ZnO. ZnO is the oxide of zinc. Then it is again reacting with the acid. I am taking 2 moles of HCl here. This is an acid, right? To form ZnCl2. Again a salt is forming here. Plus water, right? So it is reacting with the acid, so act as a base here. Then another case, if I am reacting it with the base, ZnO is reacting with NaOH, it is a base, right, strong base, to form Na2ZnO2, sodium zincate plus water. So it will act as an acid here. So these are the 2 types of examples of amphoteric oxide. One is the aluminium oxide and another one is the zinc oxide, which can act as both acid as well as base. Is that clear? Yes, Arush, just think about that. If you can see any of the oxide without any oxygen. If it is there, please give me any of the example. Okay, I hope it is clear for everyone. Now let me move to the next topic. How the iron is reacting with the oxygen. How the iron is reacting with the oxygen. In the case of iron, they are reacting with oxygen as well as the moisture, water content in the air also. So it will form Fe plus O2 plus water gives Fe2O3 dot XH2. This is known as the rust. As we already know, rusting of iron, right? Okay, we will be discussing this part in detail in the last session of the, last part of this chapter. This is the basics of rusting of iron. If iron is kept in a moisture content for a long time, it will feel like that there will be a rust is formed on the metal surface, right? That particular reaction behind this reaction is known as the, that particular reaction behind the rusting of iron is the formation of Fe2O3 dot XH2O. This is known as the rust that is forming. Is that clear? Okay, fine. Yes, correct. Carbon monoxide is a case, right? Yes. In our particular case here, AlCl3 does not consider as an oxide. It is a salt only, which is formed by the reaction between aluminum oxide and the oxygen. Clear? So here, as according to all of the reactions, we can say that both potassium and sodium can easily or vigorously react with the oxygen to catch fire. So it will be kept immersed in the kerosene oil. If I keep outside, it will easily catches fire, right? That's why these two metals, sodium and potassium, because of their high reactivity, they are kept inside the kerosene oil. So this question is very important in your examination point of view. Which are the two metals which is used in the, which is always kept in the kerosene oil. Clear? Then, if you are talking about the magnesium and aluminum, right, they are forming the corresponding oxides, which means that they are forming a protective layer over it. In the case of magnesium or aluminum, they are forming, at room temperature, they are forming a protective oxide layer over it. So that's why they are using as a method to prevent the corrosion. Again, we will be discussing detail in the last part of this particular chapter about the corrosion, how we can prevent the corrosion and so on. So here you need to keep in mind that the magnesium and aluminum are the particular metals which will react with the oxygen to form a protective oxide layer over it. Clear? So far we have discussed about the reaction of metals with air, right? Reaction of metals with oxygen. Now let us see how non-metals are reacting with air. How non-metals are reacting with air. Hi Durgeshwar, good evening. So again, the non-metals are also reacting with the oxygen to form corresponding oxide, right? Corresponding non-metal oxide, but they are acidic in nature. They are acidic in nature. Now I have a question for you. If I am placing a litmus paper here, what will be the color change? This is an acidic oxide, right? This is an acidic oxide. If I am taking a blue litmus paper, what is the color change there? Or how we can detect the particular non-metal oxide is acidic in nature by using litmus paper test. Yes, it will turn blue litmus to red, right? Similarly, if you are taking the metal oxides are basic in nature, right? So it can turn the red litmus to blue. So keep a note on that. Clear? Now let us see the first example here. Carbon is reacting with oxygen, right? Carbon is reacting with oxygen to form carbon dioxide. That is one of the example for the non-metal oxide is using here, carbon dioxide. Then another one, this carbon dioxide reacting with NaOH. NaOH is base, right? NaOH is a strong base. So it will react with the base to form corresponding salt, that is Na2CO3 or sodium carbonate plus water. Due to the reaction between acid and base, that is neutralization reaction. So we can say that carbon dioxide is acidic in nature, right? Acidic in nature. Now let us see another example of sulfur here. Yes, sulfur is reacting with oxygen to form sulfur dioxide. That is another example for the non-metal oxide. Again, if you are taking the NaOH or the strong base here, whenever they are reacting with the SO2 plus NaOH, it will again form Na2SO3 plus H2O, which means that it will react with the base to form, act as an acidic oxide here, right? Okay, this is the example to show that they are acidic in nature. I hope it is clear. Okay, so far we have discussed about the reaction of metals and non-metals with air. I hope you understand all the part how they are reacting. The metals are reacting with the oxygen to form metal oxides, right? If they are forming the metal oxides, they are basic in nature. Some of other cases are also possible in the case of amphoteric oxides, right? In the case of Al2O3 or zinc oxide, they can act as both acid as well as base, so they are known as the amphoteric oxide. Then if you are treating non-metal with oxygen, they are forming the corresponding non-metal oxides, right? So these non-metal oxides are generally acidic in nature. Then one more exception is there. If you are taking, I will write here, if you are taking carbon monoxide, nitrous oxide, then water, these are the oxides of non-metals, right? This is the oxide of carbon, this is the oxide of nitrogen, this is the oxide of hydrogen. So these three examples are the examples for the neutral oxides. They are neutral oxides which is formed by the reaction between non-metals and oxygen. Clear? This is also very important. Now let us practice some questions based on the topic we have covered. Here is the first question. Okay, please give me the answer first, the comments. Metal oxides are, the direct question, whether they are acidic, basic, neutral or none of these. Yes, basic, right? So option B will be the correct answer here because metal oxides are basic in nature, so they easily react with the acid to form corresponding salts by the neutralization reaction, right? So here is the next question. Non-metal oxides can easily react with. Non-metal oxides can easily react with. First you have an idea about that, what is the nature of non-metal oxides. Then you can say that it will react with whether acid, base or both. Read the question carefully. Non-metal oxides can easily react with. Arush, are you sure? Option A is the correct one. Choose any one of the option. Yes, base, right? Yes. So option B is the correct answer here. As you already know, the non-metal oxides are acidic in nature, right? So they can easily react with the base. So option B will be our correct answer. So this is a little bit confusing question. Without direct asking about the nature of non-metal oxides, they are asking this type of question. Clear? Okay, here is the next question. Which of the following is not an amphoteric oxide? Hello Tanya. Which of the following is not an amphoteric oxide? We have already seen two special cases of amphoteric oxide. Here the options are given. First is calcium oxide, zinc oxide and aluminum oxide, and the last one none of these. What will be the answer? Are you sure? Zinc oxide. Is there any other answers? Question is, which of the following is not an amphoteric oxide? Amphoteric oxide. Calcium oxide, right? Calcium. Metal will react with oxide for metal oxide, which are basic in nature, right? They are not amphoteric in nature. So among these following, these are zinc oxide and aluminum oxide. These are the exceptional cases for the amphoteric oxide. Then calcium oxide is the basic oxide, right? Basic oxide. Is that clear? Arush, I have already discussed now what you mean by amphoteric oxide. In generally, we can divide the oxides into, based on their character, they can be divided into acidic, basic, neutral and amphoteric. Acidic means they are acidic in nature. Okay, acidic means they are acidic in nature, they can easily react with the base, right? Then for basic oxides, they are basic in nature, they can easily react with the acid. Neutral means they cannot be react with the acid as well as base, right? For example, water, N2O and carbon monoxide. Amphoteric oxides means these are the special type of oxides which can act as acid as well as base depending upon the other reactant. That's why we are seeing some reactions here, right? Okay, let us take an example of the zinc oxide here. Zinc oxide is reacting with HCl. The other reactant is acid in nature, right? The other reactant is the acid. So, depending on their nature, it can act as base. I hope it is clear now. In the case of zinc oxide, if it is reacting with the acid, it can act as the base. Similarly, if the zinc oxide is reacting with the base, which means that they can, depending upon this nature of this particular reactant, it can act as an acid. So, such a particular type of oxides which can act as both acid as well as base depending upon their other reactant is known as the amphoteric oxide. Is that clear now? And two examples are aluminum oxide and zinc oxide. Arush. Okay, fine. Now let us talk about the reaction of metals and non-metals with water. In the case of first case, right, in the case of first case, I am taking the HCl, right, I am taking HCl. HCl is, as we already know, it is an acid. So if you are reacting a particular oxide with the acid, it can act as a base, right, acid-base reaction. In the case of reaction, we are forming a salt plus water. It is a neutralization reaction. I hope you have studied in the first chapter. Neutralization reaction, acid-base reaction, right? Whenever an acid and base is reacting together, they will form salt as well as water, right? In the case of first case, zinc oxide is reacting with HCl. HCl is an acid. That's why they are acting as a base. The second case, cetanoid is reacting with the NaOH. NaOH is a base, as we already know, right? That's why they are acting as an acid here. Clear? Now let us talk about the reaction of metals with water. What will be the product? What you are expecting if we are reacting metal with water? Yes, obviously hydrogen gas is a byproduct, right? So, first case, it will react with water to form metal oxide. This is the first case. It will react with water to form metal oxide plus hydrogen gas, right? So further it is reacting with the water to form metal hydroxide plus hydrogen gas. Clear? That is the reaction of metal with the water. So if you are taking any of the metals, it will produce the corresponding metal hydroxide in last. Clear? Yes, then you are correct. Metal hydroxides and hydrogen gas. Let us see some examples here. Yes. Same, we are taking the first metal here, potassium, right? So potassium is reacting with water to form potassium hydroxide, right? Potassium hydroxide. As you can see over here, again it is catching fire. Catching fire, right? Along with the potassium hydroxide plus hydrogen. It is an exothermic reaction in which heat is releasing. A huge amount of heat is releasing here. That is why it easily catches fire, as you can see over here, right? So, potassium and sodium react with cold water violently. Clear? Why they are easily catches fire? Because hydrogen gas is forming here. As a part of this reaction, heat is also forming. A huge amount of heat is forming. This will react with the hydrogen to form a burning effect here. So, because of the high reactivity of the sodium and potassium, they easily or violently react with cold water. This is very important. We need to specify the particular metals which is reacting in cold water, hot water and steam. This is another one, right? Sodium is reacting with water to form sodium hydroxide plus hydrogen gas. Similarly, same heat is also again releasing here as a part of exothermic reaction. Let us see the reaction part here. 2 sodium plus 2 water gives 2 NaOH plus H2 plus heat. In order to write all the chemical equation as according to your knowledge, you need to balance all the chemical reactions, right? And only you will get the full marks in your board exams. The next case, potassium plus water reacting to form potassium hydroxide plus hydrogen plus heat. Again, exothermic reaction. Because of this heat, it will react with it will catches fire easily with the hydrogen. So these are the two metals which is reacting with cold water easily. Cold water. Now let us take another example, another metal, that is calcium. Right? If I am taking calcium, what are you observing here? Is there any fire catches? No, right? These, yes, correct. There is the metal, calcium metals are easily floating over the water, So this is also another example of the reaction with water. The calcium is reacting with water, right? Calcium is reacting with water. Calcium hydroxide, right? Calcium hydroxide plus hydrogen This is also a type of exothermic reaction, but the heat formed is very less as compared to the previous two reactions, right? Heat formed is very less. That is why there is no fire catching is not happening here, right? So calcium does not react violently with water. They start floating. The bubbles of hydrogen gas are formed. That is why they are forming here. These bubbles are representing the bubbles of hydrogen gas forming. This is also an exothermic reaction in which heat is releasing, but the amount of heat released is very less as compared to the previous examples. Is that clear now? So we can say that calcium is also reacting with the cold water. But in a less amount, right? So as compared to the reactivity, calcium is less reactive than the sodium and potassium. I hope it is clear for everyone. Now let me move to the next example, that is magnesium. Magnesium is another element, right? Another metal, right? This is a special case. It cannot be react with the cold water. It cannot be react with the cold water because its reactivity is very low, right? Its reactivity is very low. You must be studied about the reactivity series. Then you will get an idea about the which of the metals are very reactive, how they are forming the reaction and so on, right? So in case of magnesium, yes, this is a reaction. Magnesium is reacting with water to form magnesium hydroxide plus hydrogen. Magnesium hydroxide plus hydrogen. Here the water using is hot water. Clear? Is that clear? Next, another example it is, if we are taking the oxides, if you are taking the metals, aluminum, iron and zinc, they only react with the steam. They cannot be react with the cold water or hot water. For example, if you are taking, again the example is given here. Aluminum, right? Aluminum is reacting with water, gas, water vapor, that is known as the steam, right? Water vapor, that is steam. It will react with the steam to form. We are expecting the product as an hydroxide form, but it will be forming oxide. This is very important, right? So in order to write down the reaction easily, we need to identify the product which are forming. If you are taking cold water or hot water, you will get the hydroxide. If you are taking steam, the product will be definitely it is an oxide. Clear? Okay, why are we using hot water and cold water, right? It is depending upon their reactivity, depending upon the it is depending upon the reactivity series. Like for in the reactivity series, the topmost elements, topmost metals like potassium and sodium, they are highly reactive, so they can easily react with the cold water. If you are taking along the middle of the series, we can say that if you are taking calcium metal, they will react with hot water. Magnesium and calcium are reacting with the hot water. Then the next one, aluminum and zinc, right? Zinc is reacting with steam. Zinc is reacting with the steam to form zinc oxide. Clear? Then I have a question for you. If I am taking magnesium, another possibility, if I am taking magnesium here, then I am reacting with the steam, H2 gas. What will be the product you are expecting here? Whether it is an oxide or hydroxide. Please give me the answer. I hope my question is clear. If I am taking the same magnesium metal, right, same magnesium metal, it will react with the steam, water vapor, right, react with the steam. What will be the product you are expecting, whether it is an oxide or hydroxide? What is the chemical formula for the particular oxide? Clear? So it will be magnesium oxide, which is given as MgO. I hope it is clear. So the main point you have to keep in mind that if you are treating with the particular metals with the steam, the final product will be oxides instead of hydroxides. If you are reacting with the cold water or hot water, the final product will be particular hydroxides. Clear? Now if you are talking about the reactivity series, these are the particular metals which is present in the bottom side of the reactivity series, that is lead, gold, silver, copper, right. So these metals do not react with water at all. If you are taking cold water, hot water or steam, it will not react with the particular metals because of their low reactivity in the reactivity series. Are you observing any difference in the reaction with hot water and cold water with the metals? If you are taking hot water or cold water, you are getting the same oxides, right? Same hydroxides only. But the difference is that depending upon the reactivity of the metals, they will react with the hot water and cold water. For example, for the highly reactive metals, sodium and potassium, right? Sodium and potassium, they will highly react with the cold water vigorously because of their high reactivity. For example, if you are taking calcium, magnesium or so on, they will react with the hot water because of their less reactivity. So you will get an exact idea when you are studying about the reactivity series. Fine. Arush. So this is a special case of elements which does not react with the water at all. Even though they are metals, but they does not react with the cold water, hot water or steam. I hope you understand. Now let me move to the next reaction, that is the reaction of non-metals with water. Before that, there is a reactivity series. This is the basics of the reaction of the metals with oxygen as well as water. If you have the idea about the reactivity series or the activity series of the metals, you will get the correct product, how they are reacting with the water, whether it is reacting with the cold water, hot water or steam, right? So what you are observing here, the first metal, right? First metal, potassium, right? This is the most reactive metal, That is the first case. If you are recalling the reaction between the oxygen, right? Potassium and oxygen, you will form the potassium oxide by catching a vigorous reaction, by catching fire, right? Then next one, sodium, then calcium. So if you are talking about the potassium and sodium, right? Potassium and sodium, they will react with the cold water, right? Even calcium is also reacting with the cold water, but the reaction rate is very low, right? Bubbles, so hydrogen gas is forming in the reaction between calcium and water, right? Then magnesium, it will react with the hot water. Then what about others? Aluminium, zinc and iron, right? Even tin is also fine. It will react with the steam to form corresponding oxides. Then lead, silver, gold, copper. Even mercury is also fine. Does not react with the water. Clear? This is the basics of reactivity series. You will get an exact idea when you are learning about the reactivity series completely. The topmost elements are highly reactive. These are the arrangement of metals in the decreasing order of their reactivity. That is the thing I have repeated here. Most reactive elements are easily react with the cold water. Then middle of the series, all the elements will react with the hot water. Specifically, you need to keep in mind that magnesium is the one which is reacting with the hot water. Then all other elements are aluminium, zinc, iron, and tin. They are reacting with the steam. Then rest of the elements does not react with the water. Clear? So you need to remember all the metals in the reactivity series in the decreasing order of the reactivity. You can use any of the code for that. Clear? Now the last type of reaction is the reaction of non-metals with water. Non-metals with water. Do you think that non-metals are reacting with water to form non-metal hydroxide? Reactivity series are different in different books. This I was taken from the NCERT textbook, I think. You can refer your textbook only for your board exams. Okay, most of the cases it will be similar. Only the difference between here, I think. Here it will be platinum. Then in between some of here, I think it is carbon is there. That is the only difference. Now, what will be the reaction of non-metals with water? Okay, we will predict that non-metal will react with water to form non-metal hydroxide, right? But in general, the reaction does not happen. Again, you can recall the idea from your chapter, chemical reactions in equation. It will be about the oxidation and everything, right? So, if you are talking about the metals, there will be the metals are electropositive, right? Metals are electropositive, they can donate the electron, right? Electropositive, they can donate the electron. But in the case of non-metals, they are electronegative in nature. They cannot donate the electrons, right? They can accept electrons only. That is why they are not reacting with water to form the particular hydroxide. I hope it is clear. Because of their electronegative nature. So, non-metals does not react with the water to form particular hydroxides. So, here is the question based on the next part. Which of the following metals follow exothermic reaction pathway when they react with water? Options are given here: aluminum, zinc, sodium, and none of these. Which of the following metals follow exothermic reaction pathway when they are reacting with water? Sodium, right? So, option C is the correct answer, sodium. So, if you are talking about the aluminum and zinc, right? If you are talking about the reactivity series, this is around the bottom side of the reactivity series, right? So, aluminum and zinc are reacting with the steam. Instead of cold water or hot water, they are reacting with the steam, right? Gaseous water to form corresponding oxides, right? To form corresponding oxides. Then if you are talking about the sodium, it will form the corresponding hydroxide by releasing heat, right? So, it is an exothermic reaction. So, option C will be the correct answer here. Now, let me move to the next question. Which of the following metals do not form hydroxide when they react with water? What will be the answer? Do not form hydroxide when they react with water. Calcium. This is the reason aluminum is the only one which is forming metal oxide. So, sodium, right? Sodium, whenever they are reacting with the water, they will form the hydroxide, NaOH, right? We have seen. Then calcium plus water. Calcium hydroxide plus hydrogen, the bubbling, right? Floating on the water. The next one, potassium. Potassium plus water, potassium hydroxide, right? Aluminium is reacting with the water, but is specifically asking about the, we can specifically say that it is reacting with the steam. Even though it is water, but it is in the gaseous form, right? So, whenever the aluminum or zinc, which is reacting with the water or the gaseous water or the steam, they will produce aluminium oxide, right? Aluminium oxide. So, our question is which one of the not following? Which one of the following is not forming the hydroxide? That is the one which is option C. I hope it is clear. Arush, is that clear now? Yes, okay. Here is the next question. Which of the following is reactive towards water? Reactive towards water. Read the question carefully. Which of the following is reactive towards water? we have already seen, right? Some of the elements, some of the metals which is in the reactivity series, depending upon their reactivity, they cannot be react with the water. If you have the idea about that, you can easily answer this question. Okay, what will be the answer? Options are given: lead, copper, gold, and none of the above. Arush, are you sure? Copper? Option D is the correct answer, that is none of the above. As we already seen, right? Ridhima, option D is the correct answer, none of the above. So, as we already seen, right? Lead, copper, gold and silver. Lead, copper, gold and silver, which is the very bottom side of the reactivity series, right? So, they are not reacting with the non-reactive or not reacting with the water. So, obviously option D will be the correct answer, right? None of the above. Is that clear, Ridhima? Yes, fine. Yes, metals are sonorous. We have already covered in the first part about the physical properties. We have seen that sonority of the metals, right? So if you're taking any of the iron metal, just struck on a hard object, you can hear a sound, right? For example, we are using in the school bells. So the metals are sonorous in nature. They can produce sound when we are struck with the hard objects. Clear, Ridhima? Okay, that's all about from my side for today. We have successfully completed 2 types of reactions, right? In the first part, I have prepared only these much questions based on the chemical properties of part. Once we completed this chapter, we can prepare more questions, right? So, in the first session, we have covered about the physical properties of metals and non-metals. In this particular session, we have already discussed about the chemical properties of metals and non-metals, right? Chemical properties of metals and non-metals, which means they are the reaction between air and water. So, you need to keep in mind about the different metals, how they are reacting with the water, whether they are reacting with the cold water, hot water or steam, how they are reacting with the oxygen, how they are forming the corresponding oxides, right? So, make a note on the reactivity series also, it is also very important. Okay, I hope you guys all understand everything. Now in the next part, in the tomorrow, I will be coming back with the another part of the metals and non-metals, discussing about the chemical properties of metals and non-metals, specifically about the reaction with acids, dilute acids and the ionic compounds. Fine. So see you in the next class. In order to learn the reaction, just try to write down in your paper and repeat it in a daily basis. It will be better. Arush. You must keep a note about the reactivity series there. If you are talking about the reactivity series, both gold, lead and copper, right? Gold, lead and silver, they are in the bottom side of the reactivity series, which means that reactivity is very less as compared to all other metals, right? It's not about the high reactivity, the reactivity is very low. So you must have an idea about the reactivity series completely. What are the different metals in the reactivity series, right? So try to memorize all the elements, all the metals in the reactivity series by using any of the code. Okay, I think we can wind up the session for today. It is already over. So see you in the next class, tomorrow. Till then, bye bye all of you. Take care. Thank you so much.